on this computer. Let's go. Okay. Anyways, so we have merch here, the end of mathematics. Thank you, Emilio. Very nice. Math and stats. The Russell hoodies are only $50. I think it's a good price, especially considering a lot of other student groups would sell you a Gildan hoodie for that price or something along those lines. The quality is going to be what you expect from any other Russell hoodie. They should last a while. We have t-shirts and long sleeves. You'll see more on the Discord.
Yeah, I'm definitely getting a long sleeve of that. They look awesome.
Very nice. Also, we have free help sessions in McLean 201. That is the location I'm currently in. So you literally can ask anything. It doesn't have to be math or stats related. You don't need to be embarrassed. We are basically just sitting here twiddling our thumbs if you don't come. So
can you get a Discord link?
Link to the Discord. Yes. Okay, that might take a hot minute.
Actually, you know what? I'll
Thomas can do it. Yeah, so if you have any other problems with MATLAB in the future, then please come to our help sessions. You can also pretty much ask on the Discord at any time. Our help sessions are different from the Murray Library help sessions because we are taking these higher level math classes with you right now. So we have a good perspective on what you're going through, especially if they've been recent classes. So yeah, I think that's all of the announcements that I have. So first and foremost, you might be wondering how you get MATLAB. So the method that I use and have been using for 4 years now is to just keep hot swapping the free trials. So I'll show you this right now. If I just sign in, okay. That it doesn't have to be a different email account. You just go into the my account, and then there should be this button here, get a trial. You click on the button, you get a month of free MATLAB, you download MATLAb, you can just keep doing this. It expires in a month, but you can just go back to the same place, click get a trial, and use MATLAB again. So I do not own MATLAB. You don't need to own MATLAB. And using MATLAB on your own computer is a lot better than having to walk to the university or use VLab or MATLAB online. So, though granted, lots of campus computers have MATLAB on them. You are right, Cassandra. So there is about 1 day where you won't be able to use MATLAB, but you can't request another free trial. That's not really a problem for the most part. Yeah.
You don't just get another account, right?
You can, if push comes to shove, just get another account. That's okay. Or use VLab. Though granted, no, I want to note that
I'd rather die than use VLab.
Yeah, it also will not save your files if you aren't in the so-called V directory. So I'll just sign in to that real quick to show you, but yeah, there's been a couple of people who have lost a bunch of progress because the MATLAB timed out, or no, VLab timed out, or they're in the wrong directory.
If you don't mind me asking, I can copy and paste from that onto my computer, but I don't know if I can copy paste from my computer to VLab. Is there any way to do that?
Yeah, usually for the most part, I'm able to just like Control V. It just takes, it's a little weird sometimes. You can also upload and download files to and from VLab using this button on the top right, download files, upload files.
Okay, that's good to know.
And yeah.
There's a lot of files there.
I don't know if I could, does this V directory even show up anymore? Yeah, right there. So if you're in C, then nothing will save. Okay, with that out of the way, I can start actually using some MATLAB. Are there any final questions about getting MATLAB on your own computer while it boots up? The unfortunate thing about MATLAB is it does take a little while to boot up, but yeah, so this is what MATLAB looks like. This is probably what you're going to be seeing most of the time. So what we typically work with is this scripting editor, and then also the command window here. What the command window does is I can enter in any commands I want, like display foo, and it will print things out without me having to save a file and like go through a whole rigmarole. I can set variables x equals 2, y equals 4, and then go x plus y. And I can use it essentially like a calculator, which is pretty nice, definitely convenient. Yeah, I'm just trying to reorganize things. Yeah. So yeah, that way you can do some work just quickly. You can even like define a matrix 2, 3, 4, and do other things with these variables. Let's say there's a bunch of work that you want to save. Like I really like this matrix A in this vector 1, 2. Then I will have to make a new file on the right there script. I'm not going to give it a name because I don't really care about it. And then I'm going to have to like copy and paste all this stuff I have in the editor in here. And so now I can execute this stuff as many times as I want by hitting the run button, and I get A times X, no problem. Some very nice quality of life things that you want to keep track of is mainly just the help command. So if there's ever a function that you don't know the name of or don't know exactly how it works, then you go help and then the function's name. Say I don't remember what the function I does. Then it will give me a whole listing of how I'm supposed to use I, as well as some other different, as well as an example here. Or I can go help ones. There's some other functions below that you can hop between. And then there's also a documentation page with lots of other examples. So that's usually like typically you're going to just Google things if you don't already know the function name, but the help function is a very convenient way to just quickly remind yourself how things work. So you probably have already seen now that Matlab is a scripting language, so we don't have to go through the rigmarole like C or Rust of just compiling our programs. We can just run them. That's all there is to it. And so then debugging is a lot easier. Yeah.
Do we have to set up the environment variables?
You don't need to do any setting up environment variables. You can just, I guess by environment variables, like you mean the stuff on the right here?
Like the Python things?
Like
for the script, right?
Oh yeah, I guess you're probably thinking of like whatever you had to do for NumPy in order to get that working. Yeah, Matlab just works out of the box, honestly. So as long as you have a free trial, then it should be chill. Yeah, I'm not sure why Python makes people go through that whole extra setup, but yeah, so for our main example here, I'm going to be talking about plotting functions quite a lot. So I'd like to draw a little picture here. No audio, got it. And then I'd like to share my iPad's screen. So in order to plot a function, you probably remember this somewhat from grade school, is you want to evaluate your function f at a bunch of different points. You probably remember making a table of like x, y, 1, 2, 3. Say the function is f of x equal to x squared. Then you have 1, 4, 9, and then draw some dots, then connect those dots. So the algorithm is going to look exactly the same or very similar in Matlab. you're going to define a vector x, which is these 3 input values here, and then you're going to compute f of x to get all these y values there. So let me stop sharing my iPad screen. Share this. So to bring things back to something familiar, which is Python, you probably, I don't know if this looks especially familiar. What I do here is I generate 100 points using this range function appended to a list x, and then for each value in x, I append sine of x to the vector y, and then I plot that using Matplotlib. How about we simplify this using list comprehensions? That gets rid of the for loops and makes it look fairly concise. I'm just computing sine of all these x values. And this here is essentially a linspace, if you've ever heard of that. And in fact, you can go even further with NumPy. Import NumPy, use this linspace command to subdivide the interval -4 to 4 using 100 points, and then go sine of x. But then there's the equivalent code in Matlab, which is even more concise. There's no imports, there's no explicit loops. It's easy to write because we're going to do this really often. That's the convenient part about having a language that's designed for numerical analysis or for just math, as opposed to whatever computer scientists do, who knows. So if I just copy and paste this code snippet from the slides, I should be able to, you should be able to access my slides this way, through this URL. And then you can copy and paste things as you see fit. Does that actually work, Thomas?
Pardon, what?
Okay, yeah.
Oh yeah, I see the slides.
Very nice. Yeah, so you can copy and paste these things in. Now when I hit run, then I see a nice little plot of sine from -4 to 4. Looks very cute. So this operation of applying sine to a whole vector is incredibly concise. It's just sine of x, where x is not a number, it's a whole vector. And I note here, typically, the better that you are at linear algebra, the better you will be with Matlab. So some more about plotting. What happens when we try to plot sine of x from -100 to 100? And so I'll actually go help linspace and see linearly spaced vectors. The first entry is the start. The second entry is the end. So if I go linspace 0, 1, then I get 100 linearly spaced points between 0 and 100 and 1. And you can see that in the command window. This is a very nice place to like debug. If I go linspace 0, 1, 10, then I only get 10 linearly spaced points. And I can even play around with this some more. Go 0 to 2, 1 to 2. This is a very convenient use of the command window. I can just run some code very easily. So I've done this here with linspace. When I hit run, and wait a moment, I suppose. Oh, no, I don't have to wait a moment. The figure's over here. I get this plot that does not really look like sine of x at all. And so the issue with that is that there aren't enough points that I'm sampling from. I'm only sampling from 100, but sine x between -100 and 100 is a little too crazy for that. If I sample instead of 1,000 points, then I get something that looks much more like sine over that long interval. And I can go even further, but then I might actually just be like wasting resources. The last picture already looked fine. There is another workaround, is we can define vectors using this colon. So same bit, I go -100 to 100. I'll even show you this in the command window. And I get 200 points between -100 and 100 because I haven't specified a spacing here. If I say the spacing is 0.1 with that third entry or second entry in the middle, then I get a bunch of points. Who knows how many points? I haven't counted, but the spacing between each of them is 0.1. And let me zoom in here to kind of show you. Yeah, the space between these two jagged points is going to be 0.1. So you're typically going to use linspace or these colons. They're very convenient operators. Sine wave of sine waves, indeed. That is how wacky it gets. So now I have another example, a plot of x squared on -1 to 1. And now I have coyly, is coyly the right word for that? I have asked you the question, will this work? Now I haven't told you why it would or wouldn't work yet. I guess the first spoiler here, it won't work. And if I try to hit run, that's because there's multiple uses for this caret operator here. So what it's trying to do right now is go x times x, but it's kind of awkward. Who knows what a vector times a vector is supposed to be? Maybe x transpose x. That's a valid definition. But what we actually want to do when plotting the function x squared is we want to square each entry of the vector x individually. So if I put this dot in here, then it's squared entry-wise. And I can try and show you that with a smaller example in the command window. Sorry, I have to close this plot. So if I have 1, 2, and I go caret, it's not going to do anything. But if I do dot caret, then it squares each entry of that vector. So this is a, once you get comfortable with these dot functions, then MATLAB becomes a much more usable and powerful language.
Yeah, I'd say similar to a map, right?
Yeah. Map, like the functional programming thing.
Oh, I thought it was like isn't that a Python function which maps like a function to? Yes.
Yeah, to each entry in a
Yes.
list.
Yep.
Yeah. So yes, if you've done any functional programming, map is exactly it. Here I talk about matrices and vectors again. So if I say A is this, V is this, then I can go A times V to do matrix vector multiplication right there. And I get the correct result. And now another question I ask is, will this code work? This is yet another kind of a tricky problem, which highlights some of the growing pains of MATLAB. I'm just gonna paste this in here. Can we place our bets in the comments? Thomas says no.
No.
You say no. Cassandra says no. Akash says everyone says no. I think you guys have started to catch on. So the issue is that this 1, 1 is a row vector. And I don't really have a definition for a matrix times a row vector. I can
Transpose it.
I can transpose it. I was gonna move it to the left.
Oh,
I can do that. And yes, I can transpose it with this quote. I can also just, instead of using a comma, use the semicolon to do columns. So now I have a matrix times a column vector. So that's another thing I want to point you towards. MATLAB is pretty good about figuring out your dimensions are wrong. So you're probably doing matrix something incorrectly. Their error messages are typically fairly useful. And here I make an explicit note. Oh, Sam was the rebel and said yes. I like that. I gotta catch you guys with one of those someday. So here I make an explicit note of what I said earlier, that numerical analysts like to take a one-dimensional function and apply it to a whole vector in this way. This is how we like to extend the definition of any one-dimensional function to n dimensions, because it's particularly convenient. It's also genuinely fast, which I try to show off a little later on. And here I have some more explicit examples with sine. This one applies sine to each entry of this row vector. And over here, I have log of a matrix, which is also pretty awkward, but simple enough. It takes the natural log of each entry in the matrix.
Does it just treat like constants as 1x1 matrices?
Yeah, it's safe to think of it like that. Yeah. Yeah, I'm fairly certain. Can I actually go like 2 times A? Or A was defined in a previous session.
Oh yeah, this shouldn't work if it's.
It does. I'm fairly certain MATLAB just ignores the square brackets
Okay.
in that case. And so yeah, I make an explicit point here that like you are an expert at MATLAB if you're thinking about vectors. Everything you do should, somehow come back to vectors one way or another, because they're genuinely fast. And it's contiguous memory for anyone who knows that. Oh, matrix dot sign. I don't think so. Yeah. It doesn't have member functions defined like that in terms of a map. Yeah. Yeah, no, sign is just defined in some other place and is just willing to accept matrices as input. Yeah, your own functions should work with vectors in this way, ideally, which will genuinely make your code run faster and is typically more easy to read. Easier to read? Yeah. So for an explicit example of one MATLAB program, I have Monte Carlo integration. So you don't necessarily need to already know this algorithm. I just want to generate n random points from the square 0, 1, 0, 1, and then compute f of those random points, add that all up, and divide by n. So how might we do that? We're going to go, you want to check out maybe help rand. Granted, I already know what the function is, but it's a fair guess to go help rand. You can also, I'm going to go MATLAB random number. You can typically come up with a MathWorks page on this. So the guys who made MATLAB are developing a lot of documentation for their language. This is professionally made. Pretty much every function you ever work with is going to have a page on the MathWorks Help Center. So here we have an example of rand. It gives you a bunch of different signatures and some examples. R equals rand 5. So I want to generate a single random number. If I do just rand, then I get one. I would like some x to be rand. Wow, okay, hold on.
Yeah, awful good.
For this example here, I have compute with f of x y equal to 1 divided by 1 minus xy. So right out the gates, I'm going to talk about what the syntax is for defining a function. It is kind of awkward. For the most part, you just need to memorize this and just do it. So this is a function named f with 2 inputs, x, y, and whatever r is returned at the end of when we hit end. So I'd say r equals 1 divided by 1 minus x times y. That is exactly the syntax. And I can test this by going f of 1, 1, 2. And I get a correct answer. So I want to sample a bunch of random points from this. And when I say might be a generic number of points, I'm going to start with some variable n, call it 10, and then go f of rand. You can see that does output a random number. So I'm also going to make another variable t. I'm going to initialize it to 0. That's going to be a running total. I'm going to go t equals t plus f of rand. And if I hit run, then I output this last statement here. And then also I want to note that these semicolons are not necessary. I can take them all out. And what happens is MATLAB will spit out every time that variable is used. So I output n equals 10 on the first line, t equals 0 on the second line. This is a really convenient debugging tool. I don't need to go in Python, I'd have to go print t and do this nonsense. No, over here, it's just a matter of removing one character.
What would be the purpose of disp then, or display?
Disp. You don't usually need to use it,
Okay.
honestly. Yeah. For anyone who forgot how MATLAB works, I think there are probably special cases, but I very rarely use disp. So yeah, now I will. The naive way to do this is to just copy and paste this, say 5 times, n equals 5.
What's a loop?
And then I'd go ti equals t divided by n to get the average. I guess in this case, just t over 5. And I get kind of a decent approximation here. Though granted, this is exactly what we would want to use a loop for. And the syntax for that is for I equal 1 to 5. And so this is the colon operator again. We have actually made a vector and it indexes into that vector on each loop iteration. And then I will have that over and now I can simply run it. But also this magic number 5 is kind of silly. So I'll remove 5 and replace it with n. And then I can even go 100 here, make it really large, though also there's no semicolon right here. So it's kind of crowded our output. You notice I also had a semicolon on line 7, so that's a bug. I wasn't actually getting the answer at all. So here, now I just have the single output, which is the our approximation here, or the approximate average value of this function here. So I would like to note right now that this is not the MATLAB way of doing things. In particular, we're using a loop here. And the beautiful thing about MATLAB is that you want to do everything, or you can do everything in your power to get rid of as many loops as possible. First of all, this is going to be slower than what I'll show you. Second of all, it's looks a lot more clunky. So I'm going to comment this out. Everything with the % sign is not going to be run. I get rid of the loop and observe from help rand that I can create a vector of random numbers using this rand n or rand mn. In particular, if I go rand 1, 10, then I get 10 random numbers. This is particularly nice because now I can apply my function to these random numbers. 1 end, 1 to n. I'm actually going to make 2 variables, x just equal to 1 end. y equal to rand 1n. And use a smaller n value for debugging purposes. I go x, y. Ooh, emojis.
Are emojis valid characters in MATLAB or?
I don't know.
Yeah.
And so if I just run this, it's not going to work. Why? Because I haven't defined this function f for vectors. So typically that just involves adding some dots before operators. Like the slash, I can use a dot there. The star, I use a dot there.
And that'll still work for scalars as well, right?
Yes, that still works for
Yeah.
scalars. And so by simply putting dots in places, I have defined this function for vector inputs.
Okay, where do we put that dot? Like,
Typically, you're going to want to put dots before stars, divide, or division signs. But you see here, I didn't put a
carets.
dot between, yeah, and carets. I didn't put a dot before minus because matrix addition is already entry-wise.
so basically, dot before the first operand.
Well, I can't just by the first operand, do you mean just the division sign there?
So like because carry from left to right, right?
Mm.
So the first operand and the second operand, then they compute the value, and then I mean, like, how do I say that? How do I say this? Like,
Yeah, I guess. Do you want me to remove the dot from the second star?
what if you put a dot like behind the y? Like, should it work or not?
Behind the Y? Like that?
No.
I know. Like this?
Yeah, behind the y. Yeah. So,
Okay. And just the single dot there, it won't work. That is a syntax error. MATLAB expects the dot before the operator.
Do you see the suggestions in chat there?
Oh no.
Oh, just at the bottom
Lawful good development formatting, getting a specific
for
value.
display.
Could you change it to f.y? Ooh, that's Julia syntax.
oh, is it like a tie cast, like from vectors, like from normal?
I don't think that'll do a typecast. No. Yeah, no. MATLAB isn't like Julia. That was something that the Julia devs added after years of pain. Yeah, I know you have to manually go through and add the dots in every specific operator.
Control F asterisk.
Yeah. And so now I want to sum up this new vector here. And so typically what you'd go is help sum, and sum takes in a vector and adds up all the entries, kind of like a reduce, if you know what that means. And I get this value here. I can simply divide that by n and get a lovely little approximation to this exact thing here. So now let's go n equals 1,000, maybe even 10,000. You might notice that this is starting to approximate pi squared over 6 pretty well, which, funnily enough, is the value of a very particular integral, but it's not important which one. If we want to definitively say which one is faster, we can use this tick tock command here. We go tick tock, and now I don't even really care, or I'm going to uncomment this. So for 10,000 entries, oh, tick tocking like the wrong way. For 10,000 entries, the first is 5 times slower. Let's go 100,000. The first now is,
Oh God.
well, it's slower, definitely
Yeah.
slower. Let's add another 0. It is 10 times slower. Maybe another 0. And each time we add a 0, we're getting more and more accurate approximation to pi squared over 6. Note that as well. So we do actually want to use a value of n that is this large. Once again, it's about 10 times slower to use a for loop. And this is a general principle that for loops are in fact slower because the vectors can take advantage of what are called simmed operations. If you care at all about that, just know that there is some computer magic going on behind the scenes to make the vectors way faster. Yeah, I think that is all I have to say about that example. Now, I'm gonna grab some water. This is a series I like to call MATLAB is jank. So there will be lots of very terrible examples of moments that will cause you hours of pain that you should look out for. Need my map2 operator. Yeah. First and foremost, matrix or vector entries start at 0. So here's the first time I'm showing the syntax to index into a vector. I'm going to actually give this a name. What we had before, Montcar. Oh no, I already have that.
Montcar 2.
Mcar. Yeah, Montcar 2. And I'm going to make a new script, just leave it untitled because I don't care.
You didn't care last time. And look what
Yeah.
happened.
I didn't care so much, I needed to name it. So yes, this fails. Now, will this code fail? Please, I ask you to submit your guesses.
I mean, I hope it fails, but I don't think it's going to.
We hope it fails.
Because it would make sense if it would fail, but
Do we all hope it
wait,
fails?
1, 2.
Let me I'll show you
Wait.
what this 1 to 5 is.
Oh no, wait a minute. It's not, it's inclusive, right? So,
It is, but there's not 6 entries in
oh wait, yeah, I mean, I can't count.
There's 5 entries, it'll return 1. Maybe it will fail.
Wait, will it return the length maybe? Maybe it has the length at the end. That'd be stupid. You want the length at the start.
I guess the length is 6, but like, yeah, I don't know.
I'm just spitballing.
Sam knows it won't fail, and it doesn't fail. It works perfectly. And I can even do this like with 3. Works just fine because MATLAB vectors will just grow. It allocates more space and gives you a slightly larger vector. You can see that it fails if I index into it, like usual. But yeah, not if I assign something to the end.
So just have the possibility of like moving it around in memory, because like this all has to be contiguous, right?
Yeah.
So it might be at a point where, you know, there's no more space, but it has to extend it.
Yeah, you can. It's really slow to
Okay.
add things on like this.
I think that'll work too.
Let's see, v of 8 equals 8. We can even see the output right
Oh,
here. It skips over 7, just says that 7 is 0.
Does it always do?
Yeah, it should. At least in my experience.
Okay.
Yeah, MATLAB indexing is very sadly the chaotic evil of indexing. And here I have a matrix. Let's just throw in here. What on earth would
And
yeah, here I show off end is the last entry in anything.
is there a start? Or...
The start would just be 1.
Okay, yeah, I guess you don't really need to.
And
Special variable.
yeah, if I add these plus 1s, then this will be a of 3, 3. Which I can show you this in the command window, a of 3, 3. It fails, but if I run the code, fills in with zeros, and I can go a of 3, 3 equal to 5.
Can you assign to A0?
Let's see. I guess A00 equal to -1. No.
Okay, good.
Array indices must be positive integers or logical values. So, okay, you can very clearly see that the MATLAB is jank. Now, here is going to be a particularly devious one. So
That's why you want to do clear in CLC.
yeah, say in a previous session, I've like had this variable j defined. You can see it on the right here. And if from then on, my whole life, I've just been working with this j variable willy-nilly, I cannot submit this. It will fail on anyone else's computer that they try to use it on. In fact, if there's another function here, like I've defined this x value in a plot. Now I can just refer to this x value in this other script, no problem, despite this program not really being kosher. So I would like to point your attention to that, at least. The solution, belabor this point here. Oh yeah, I talk about how you can get into a column of the matrix A. If I go A, J, colon, then I get the first row of the matrix. This colon operator is for referring to an entire row or column. But yeah, you can't just say AJ. I should explicitly say 1 or include that in a script. So the solution here is to start every program with clear vars. And now if I go clear vars, all of the stuff on the right dies. And the program correctly now recognizes that X has never been defined before. Yeah. Furthermore, I belabor the point about the dot operators once again. Usually the trick, whenever somebody asks you to find some bug in their code, it's because they use the dot incorrectly. So I have some examples here. The star might mean matrix multiplication or entry-wise multiplication. This is particularly devious with a square matrix here. If I go A squared, that's not entry-wise squaring each. Yeah. It's actually doing A times A, which is very different from A dot caret 2, right? But Matlab isn't complaining in the first or second case. You might do one or the other accidentally with just A caret 2. There's also the same problem with the division sign.
Matrix division.
Matrix division is something a little peculiar. If I do 1, 2, 3, then just hit run. Then matrix division is a legitimate thing. I talk more about this later on. And so this is different from dot divided by X. And I can't do that type of division sign, but yeah, like these are all valid commands here. You should figure out exactly which one of them does and which one you want. And here I also talk about what exp A is. It applies E to the whatever on each entry, but there is an exp M of A that's different. This like E to the A that you might have seen from math, it's not the same as exp A.
Is there an E in there by default, or you're just going to say E equals X1?
Yeah, there's no E.
Okay.
You just go exp1, but there is a pi for by default, which is really convenient. I really wish C++ didn't take until 2014, 2017 to make a pi constant. I don't know. Terrible. Here's also another kind of peculiar situation, is that this transpose kind of behaves weird.
What could possibly be wrong with this? This looks fine.
So I is the imaginary constant. If I throw in this vector here, I get a different vector, but this first entry has a swapped sign.
Oh,
so
no.
it does the conjugate transpose by default, which is kind of tricky.
Oh.
You might need to use a dot before the transpose, especially if you're using any complex math.
Oh my god.
Yeah. Here I have another example plotting functions. So I want to plot 1 divided by x on -1 to 1 using a step size of 1 divided by 32. A bit of a peculiar choice, but there we go. Will this code run? What is the bug in my code?
Wait, actually, are we gonna hit a 0? I need to.
This is a tricky one. This is a tricky one. Please.
Oh, well, oh, yeah,
Audience
okay.
voice. Those of you on Zoom as well. The division in X.
I think the division in Y would be the issue.
All right, yeah. On line 5, that 1 divided by X will crash my code.
Yeah.
It's because I'm not doing entry-wise division. So now I get a whole plot of 1 divided by X. Though I would like to note that if you actually go into this vector X, print out all the values.
It's gonna be a nan, right? Or
Oh, sorry, the Y, because there's a 0 here. There is an inf.
oh.
However, plot does not care. It just goes. In fact, I actually get a really nice plot of 1 divided by X because plot doesn't care.
Is there a particular reason why it's just inf rather than like negative inf or nan? Because like it you know, the limit doesn't exist, right? So
I got 1 divided by 0. If I got -1 divided by 0, 1 divided by -0.
okay.
It really just does whatever. It's this is kind of engineering math. It's convenient. It is very convenient, I will admit. And now let's see what happens if I change the step size even slightly. I get this garbage. So actually that indeterminate point was in fact really convenient back in the day. Or even no, today. Still convenient today. And that is generally the case with Matlab. It will just chug along, do whatever it likes. Here I have plot log x on -1 to 10. And I'm going to use a step size of like 0.1. I go log x. And it ignores imaginary parts. And I do in fact have outputs from log for values less than 0, which is awkward. This is but it doesn't care. And honestly, most of the time you might be in some scientific application where you don't want to care. It's kind of a pain in the ass to care. If I was in C or C++ and it said that I can't just evaluate log for -x values, then I'd have to go through this whole if statement and like try to extend the definition on my own. So this is kind of a magical application of Matlab. It just works. I'm speaking from hours of pain here, actually. It just works.
Is there a way to map complex numbers or?
Oh, like get a vector of complex
Yeah, I
entries
guess
and like,
so.
yeah, I could do like.
Well, I mean, like, can you display both the real and imaginary parts in a single graph?
In a single graph. Yeah, let me show this off. If I go y, my, and then I go hold on to get this on a single graph.
Okay.
No, yeah, I got the name slightly messed up. It's imag y and real y.
Well, that's pretty cool.
So this hold on thing here, if I don't have that, let me show you.
I'm guessing it'll do a separate graph.
It only gives me one
Oh,
plot, which is actually really annoying.
Hmm.
So thank you for asking this question. You need to remember the hold on in order to get multiple lines of one plot. And yeah, you can see this imaginary part here now. This is a very natural definition of the logarithm of x for negative values. I would also like to note that this isn't log base 10 of x. the specific question just said plot log base 10 of x. A -1, oh yeah, log base 10. That is not going to be quite right. Hold on, if I actually do 0 to 10 and comment this out, just give me the plot here. I don't know why the plot isn't updating. Oh, there we go. Just give me a moment here. Oh, yeah, because this plot is trying to plot the imaginary part of a real value, and that's why it's constant. Here we have this plot here. It doesn't care that log of 0 is infinity. Once again, if I just go y, negative infinity isn't a problem for MATLAB. This is also not log base 10, so computer scientists can't have it anyway. It's log base 2 if it's just log, it's log base 10 if it's just log, it's log base e if it's just log. In this case, in MATLAB, it's log base e. And you need to use this log 10 here. You can see it in the help to get the common base 10 log. I have lost marks on that in an assignment in the past. Another thing that's kind of jank about MATLAB is that context is critical here. The way I write a variable changes what a function returns. So if I go r equals rand 5, and remember rand 5 is going to make a 5 by 5 random matrix. If I do an LU decomp of that, I get this LU, but you'll notice that L is not actually lower triangular. So if I do an LUP, then I get an actually lower triangular L and a permutation matrix.
Or LUP?
P being a permutation matrix. So usually what you have is a PA equals LU. And let me actually write that out here. PA, oh, app designer, what in the PR and LU? Let's see what those products are. They are the same. That's what LU does. And I can even see this when I go, help LU. And they'll have some examples for me here. And yeah, the way you change output from LU all comes down to this stuff on the left of the equal sign.
So does it call a different version of the function depending upon which arguments you give it?
Yeah.
Okay.
It will. Different versions for depending on the left side as well.
So you'd be able to declare functions that are the same name, but give different outputs, or sorry, take different inputs, I guess.
You honestly, I haven't done function overloading in MATLAB. I think it's a pain in the ass.
Yeah, I don't know what people
correctly. Yeah, MATLAB is kind of stupid with function overloads. You might be getting a little too sophisticated with that. And then I also want to show you that E equal to I R. It's not the same as, what is it? VD equal I R. You see that E is just the eigenvalues, but VD is a matrix of eigenvectors and a diagonal matrix of eigenvalues is D. I also want to show off this dot operator here. Let's see here. Let's do 5 times A. What happened? What
You got rid of A.
R? Yeah, I did get rid of A. So 5 dot R works just fine because this scalar multiplication is entry-wise anyways. But then what is R plus R? Also entry-wise anyways, but R dot plus R will fail, funnily enough. What's another one?
I don't know what, because you can define entry-wise addition with matrices. It's just the same thing. So
yeah, it would be reasonable to expect this R dot plus R to be the same as R plus R. But I suppose they've decided to throw an error because maybe you don't know what you're talking about so much that It's like problematic. So here I have another example of the dot operator being absolute garbage. So v equal to 1, 2. No, 1, 2. And I guess I'll just exit this out. Now, the specific example is that v times a is not going to be the same as v dot times a. I don't even know what dot times a is going to do in this situation, to be honest. But you can see that using the dot when you don't know what the dot does actively harms you. V times a is the normal matrix multiplication there, but the dot times does some weird stuff. Yeah, the TLDR is usually the dot will make things work entry-wise. That's how you want to use it. But otherwise, if you don't know what it's going to do, don't use the dot.
Is there documentation for the dot operators?
There should be. I don't know how to get the documentation from within MATLAB, but you can certainly Google these things.
So it should be on Matlab, right?
Probably MathWorks somewhere. So here I want to quickly talk about what MATLAB's strengths are, because it is a very good, valid language. So I touched upon this earlier, that there's a huge catalog of well-documented functions. Functions tend to just work. And problems that you have are easily Googleable because the people at MathWorks have put in a lot of time and money to make all this documentation and have their own forum for asking questions. You're not usually going to use Stack Overflow. You're going to use MathWorks built-in forums or their own forum. And people are getting paid to make MATLAB do quite a lot, and it's being expanded constantly to do more. And I think that this dot syntax, this vector syntax, is genuinely very fast, is unlike most other programming languages. So MATLAB does have a pretty unique selling point. And honestly, I do love me a jank language. Yeah, like I say, the last 2 points here are a double-edged sword. So what I use MATLAB for is for prototypes, numerical experiments, and also for writing intentionally kludgy code, where a kludge is an ill-assorted collection of parts assembled to fulfill a particular purpose. Oftentimes in the real world, you just need to get something done. It doesn't matter really how you get it done. And MATLAB is a very good resource for that. So yeah, I would like to go back to our example earlier with the Monte Carlo integration and make it better in some ways, make it more presentable as well. So go back to MCAR here. So what was one of the things we learned a little bit ago? What should we start our functions with? Clear vars, yes. Clear vars is a very nice one to have. I also want to make this into a function here, not the TikTok, everything in between the TikTok here. And so that is no more complicated than just writing function.
Oh, one more thing, do the shadowing thing, but if we use the R for the function and then below, like we would shadowing a variable we redefined earlier.
Instead of using a variable.
So like if I like define variable twice, we use the most recent one or like.
Yeah, it'll use the most recent one. You can redefine variables as much as you want. Even in the command window, if I go x equals 1, 2, and then go x equals 3, it's not going to care. And you can see on the right what x is too. Yeah. So I want a function called montcar. I'm going to have it return I, which is going to be the integral. And so what does this function need to know in order to compute the average value of a function? In particular, it's going to need a function. So we'll have to give it F, whatever F is. And if we wanted to make it more complicated, we could generalize the domain to like AB cross CD. But I'm just going to leave it over 0101.
Do you assign I to something there?
Yeah, actually,
Okay.
I is assigned at the end, and I'm going to put a semicolon right at the end there too. So it's complaining right now because montcar is not in use. So I can just go tick montcar of F talk. And so even if I call this like a G function here, then I get unrecognized functional variable F. Oh, that's over here. I do my for loop, not enough input arguments. So I have to use an @ sign. Say I'm using this function here, right? And then
Oh, did you not define it?
This function doesn't know what n is. So this is a very valid way of writing a function also, is just hit the run button and see what MATLAB complains about.
You can have global variables, right? You
Yeah.
can assign n outside of it.
Yeah, if I want to do a global variable, then I would have to go global n.
Oh, okay.
So then within this scope, MATLAB will check the global scope. So it's also, it warns you, it says that global variables are inefficient, so on. You can have your debate about how global variables are.
Sorry, what does the @ sign do again?
The @ sign says, I'm not trying to call G, I'm referring to G by the name.
Okay.
Or by the symbol, rather. So this lets me pass the function G into the function montcar to do this average value thing, which...
We define the function G inside the function montcar.
Yes, so we can use this @ of xy and go just copy and paste this in to get an inline function. Those of you in the functional language sphere would call this a lambda, but yeah, MATLAB calls it an anonymous function. It's very convenient, and a nice side effect of being a numeric language is that it's built around these things. It's built around having an anonymous function, easily accessible. Yeah. And then I'm going to leave this with the @ G though, because it's kind of nice to have this here. If I really want to show off this beautiful program that I've built, then I can right click on montcar, open as live script. And this is particularly useful for anyone who has an assignment that requires you to submit MATLAB code. Once it's in a live script, I can go export to PDF, mcar.pdf.
I see an export to LaTeX there.
There's also export to LaTeX, and I get all of my code very nicely formatted in a PDF. CrowdMark takes PDFs really conveniently. It's quite nice. And then if I have a bunch of comments in here, like say, time naive Monte Carlo. And then over here for my function, approximate integral. Maybe I have a comment right at the start that says like Q1. And then I get this nicely formatted. I'm going to approximate the average value of F. And when I export this to PDF, then I get my code with its comments, which are very easy to show off in the final submission. And you know, me as a marker, I'd be able to look at what you've done, verify very quickly that it works, especially because this is all copy pastable. That's a big one. Then I know you're not lying to me. And then also if I run this, I should be able to see output on the right here. Yeah, the output should show in the PDF as well. I think I just needed to run it. Yeah, there we go. That is output after every command. there. It's very easy to verify that this all works. Yeah, that's the live script function. There. So right at the end here, I would like to show off how you solve linear systems of equations, because this is a big thing that MATLAB is good for. If there is time, a little bit about integration, with MATLAB's built-in functions, but we'll see. Now, I'm gonna make a new script called linalg. I'm going to use this a equal to 1, 2, 0, 3, 4, 0, 0, 0, oh my, 0, 5. Then I can hit run to verify that a is what I want. And then b equals 1, 2, 3, or 1, 3, 0. 1, 3, 0. B is in fact a column vector. So I can solve a times x equals b for x here by just going x equals a backslash b. And I get exactly that vector that I want. Excuse me. So this is the matrix division that I was talking about earlier. Let's see if I can do a dot. I can do a dot. Let's see if I do the wrong backslash. Okay, matrix, excuse me, dimensions must agree. Just remember that it is a backslash, excuse me, to solve the linear system. Yeah, I have this right here. And then also if b was not a column vector, let me make it a row vector here. I get a error in matrix dimensions, which is a little tricky to debug, but not terrible if you remember that simply removing the backs or the semicolon is going to get MATLAB to print about a bunch of garbage out for you. Now, yes, so here I make an argument that backslash is a really sophisticated operator. It's always going to do the best possible thing for whatever matrix A you give it. In particular, handles a rectangular A, checks that A is triangular, symmetric, diagonal, whatever, takes advantage of that. And the TLDR is a brain empty trust backslash. In particular, it's way, 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 way better than inv of A. So now recall that I could have gone and computed the inverse of A and multiplied by B to get X. And in fact, that does work. But the inverse is a lot worse. Now I don't prove it here, but inv A is typically slower. It will not take advantage of A's structure. That's a big one in particular. So it's not going to do any magic when A is triangular or has other additional structure. In fact, MathWorks themselves in their documentation goofs on the inverse. Here it is in the tips. Seldom necessary to form the explicit inverse of a matrix. And a frequent inverse or misuse of the inverse function comes when you're trying to solve AX equals B. So the TLDR here is brain empty, distrust inv A. And this is a good rule of thumb in other languages too. There's usually some Gaussian elimination solver function that you can use. Can inv handle this? Now let me actually write it out. The matrix itself is 2 columns, 1, 2, 3, 4, and then 5, 6. And going to argue with that. Does A look the way I want it to? Hit run. 1, 2, 3, 4, 5, 6. And then B is 1, 1, 1. And I have the answer over to the right. But can we get inverse to compute that for us? No, because there's no inverse of a rectangular matrix. However, you can still solve the linear system of equations. I can go A backslash B, and I do in fact get the correct X value here. Yeah. And then here I point out that the example in MathWorks inverse here has some, MathWorks has an example where the inverse matrix is way slower and has way more error. In particular, this residual is 10 million times larger, which is a bad thing if you've taken a numerical analysis class, you know that. And then you can also like solve a bunch of vectors X, like say you might have a big matrix B of vector values, but yeah, like a whole list of AX1 equals B1, AX2 equals B2. You still don't want to use the inverse of A. You can make some matrix B with all the columns and use backslash on a matrix. And yeah, I'm not going to belabor that point any further. There is a pinv function which could solve this. However, it's also way slower and just kind of bad in comparison to this backslash. Yeah. Anyways, I do have a quick example on integration, and then that's it. So typically, I've already kind of belabored this point about passing functions to functions, but like if you want to integrate sine x over x on -1 to 1 using MATLAB, then it's really straightforward. You just use this function integral. Here I can even go help integral. And it will give me a bunch of stuff here. It says argument 1 is a function, a is the lower bound of the integral, b is the upper bound of the integral. And so I can get this sine x over x. Ooh, this was supposed to be another trick question of will this code run or not?
Oh, yeah, I need a dot there, don't you?
So yeah, MATLAB actually expects the function you give it to work on vectors with this integral function. And that is because, once again, vectors are way faster than the alternative, which is just single entries. If I go help integral, I can force integral to accept scalar valued functions. Where is it? Or to accept this function not defined on vectors here with this array valued argument. But it's going to be way slower. Where is it? Invalid argument of position 1, make sure name value arguments include both name and value. Hold on a second. There's something goofy going on here. So I don't quite remember this way, but there is a way to get MATLAB to let you integrate this function without you actually going through the rigmarole of making it work with vectors. Yeah, I'm not entirely sure why it's not happy with position 1. Does array value need to be earlier?
Can it do indefinite?
It can do indefinite integrals.
Ooh.
Yes. Limits of integration must be double or single scalars. Ah, silly. Is it the single quotes? No.
Oh yeah. There's a whole thing with the single and double quotes, right? Like one of them is
a car, maybe.
one of them's like a string and the other is like an array of cars. So.
Possibly. It's never really come up in my experience. But yeah, it can do indefinite bounds if I go inf.
Oh.
And in this case, it's angry because I removed that dot. It is a single value.
That's some warnings there.
Some warnings. Reach the max number of intervals in use. So it's saying we have an error of about 4.6.
That's pretty big.
That is a pretty big error. If I go help integral, I can also check out ways to change the tolerance and change the max Intervals, I believe. I might have to actually go into the documentation though to find an example where they do this. And yeah, if I go. Okay. So I found the error with the arrayed value thing. I need a true at the end. So if I remove this dot, then it will march along even with a function that doesn't accept vectors. And right here, you can change the tolerance. Is there a way to change the number of points? I guess not, maybe. Well, there's probably a way, but I don't have it prepared. Anyways.
Guessing derivatives are pretty straightforward as well.
Derivatives, that is a bit of a can of worms, unfortunately.
No.
So you can compute derivatives symbolically with a MATLAB package, which you might have to pay more for, but it's free with the free trials. Once again, the free trials, you can do as many of them as you want. You don't need to change your email. They're super convenient. But like numerically approximating in derivatives is a bit of a different story. So MATLAB is not like Julia. It's a bit of an older language. So the new advanced technology in differentiation, which is called automatic differentiation, doesn't really work with MATLAB. But yeah, like I said, that's a can of worms.
Okay.
And like new age math too. I also have a bit about solving an ODE, but it's essentially the same. You set the interval and the initial value, y of 0 equals 1. And this solves the ODE from 0 to 1.
What does the 45 mean?
The 4-5 has to do with the method used and the order of approximation, or the order of accuracy, I guess. I don't exactly know how you'd say that. You practically just know that 4-5 is what everybody uses in the biz. But yeah, after you take a course on numerical analysis, you will know that the 4-5 is for like fourth order accuracy. I forget what the 5 is specifically. Maybe it even says in the doc.
Oh, you can just do doc and that's nice.
Yeah, right here. And it has other tips about the other versions of ODE solvers. They say it's a versatile ODE solver, and the first solver you should try for most problems. But yeah, the problem might be stiff or require high accuracy. Let's see if they say it's a medium order method. Yeah, I don't have the exact explanation for what 4-5 is, unfortunately. But yeah, I am just going to call it there, honestly. What you can do now is just try to make something. Doesn't matter what it is, doesn't have to be impressive. It can be a unit conversion program, it can be Matlab. You can just check your schoolwork with Matlab, in particular your linear algebra courses. Nobody wants to orthonormalize a list of vectors. Nobody wants to actually compute inverses manually. Just use Matlab.
Oh God, I love row reducing by hand.
Yeah.
10 by 10s.
So much fun. Some other things you can do is you can look into your particular interests. So like I said earlier, there's a symbolic toolbox where MATLAB can work with symbols, symbolically differentiate a function the same way that you or I would do. There's also like global optimization programs, image processing, some statistics, machine learning stuff. MATLAB really has been, people have spent a lot of time and money to make MATLAB do everything. So yeah, I think that is all for me. Thank you very much for tuning in. Once again, we have merch. And yeah, that's all. I guess there's so few people and it's so few people in person that you can't really do an applause. Thank you. I will be here pretty much 2 times a week, 4 hours to help you with MATLAB. Yeah. Yeah, thank you very much, everyone. If you have any last minute questions too, I am willing to take them. And I will upload the recording after the fact too.
Oh, you said the function can do overloading, right?
Yeah, there is definitely a way to do that. But I've never actually gone through the whole process. I've seen in other code bases that they have this overloading feature. But yeah, I don't know. It is a process for certain. For the most part, as long as there's no real difference between vectors and scalars in MATLAB, so you don't really need to overload beyond that, which is convenient.
Just put everything as vector just to be fine, right?
Pardon?
So like for models, the part to put it in like vectors, not like single entry value, then it should be good.
Yeah. If it works for vectors, then it'll work for everything pretty much. Yeah. Brief info about Math 313 and 336. This is a very fun question. Thank you, Siam. So Math 313, that's usually offered every other year. It was offered this fall. So the next time it'll be offered is 2023 fall, likely, unless you talk to somebody about it, like beg for them to host the class and possibly bring some of your friends in along with it too. So 313 is numerical linear algebra, where you will learn more about what this backslash operator does in order to always have a really good answer solving these linear systems of equations. You'll learn a bunch of different matrix factorizations. You will learn how people compute eigenvalues in real life, because you're not going to form a characteristic polynomial. You're not going to solve the roots of some high degree polynomial at all. That's terrible. In fact, I have an example of it. Like if you try to find the eigenvalues of a 20 by 20 matrix using the methods you're taught in Math 164 and 266, it won't work. It'll just be blatantly wrong. So in the real world, where we're solving for the eigenvalues of a million by million matrix, you're going to use much more sophisticated methods. You will learn those methods in Math 313. It's an especially good course for anyone who's interested in physics or just math in general, computer science. You're going to work with big data in the real world, so why not do it in school? And that's an actual argument for why people should hire you. And furthermore, you're going to have a project where you're going to work on. You're going to work with a real world linear eigenvalue solver and see how that works. Next year in the fall is going to be Math 314, which is numerical solutions to differential equations, which is very good for a lot of the same reasons. You're going to be solving differential equations in the same way you would in the real world. Math 336, I have not personally taken this class, but I understand it is a course on optimization. A big subset of that course is called linear programming, which has come up in my life a couple times. I genuinely know nothing about linear programming, except for that my life would be a lot easier if I knew anything about linear programming. Plus, there's a project in that course, which is a really good selling point for why people should hire you. You can collect a bunch of information, present on it on a concise way. Those are things that employers want. Employers want educators, not just hyper geniuses. So, yeah. I also, Math 336 was taught by Gary Al last semester, and I love him. You will probably also love him. Yeah, does that kind of answer the question? Feel happy with that? Granted, I think neither of those courses are needed for a math degree, which is a criminal, but so be it.
Is that okay that I come here in the help session just to ask about comp sci question?
Oh, yeah, absolutely.
Yeah.
You can come to the help sessions to ask literally anything.
All right.
Yeah, I think most of the exec are comp sci, right?
Mhm.
Or-
Doing a minor in math in addition to a major in comp sci, 313 in the fall of 2022 is a very good idea. Sorry. Mixing up a lot of words today.
All right. Thank you.
Yeah, thank you very much for coming. Yeah, there are a lot of prereqs for math 336. But you do learn a lot of really, really useful skills. And I'm sure, like, if you're just a hard worker, then it'd be okay. The professor would probably let you into the class. How's test 241? It's definitely a lot of integrals. You do some combinatorics as well, so it can be a lot of work. You do need to think about problems quite a lot, but definitely rewarding, especially if you're interested in like critical for a stats degree. I think taking stats 241 and stats 242 is going to be way better than stats 245. You're going to get a lot more out of it. But taking 2 classes instead of 1 is a pretty big time investment. So yeah, that's usually why people opt for stats 245. Yeah. Are there any more last minute questions? Stop my share. Yeah. Stats 241 is a fairly good addition to a math degree, I think, or even a math minor. It's one of those classes where if you can do a lot of integrals, then you're gonna have a better time. Yeah. 245 is kind of a must for comp sci. Yeah. You got to do at least stats 245 or stats 242, which is painful.
I still need to get that figured out because I've taken 2 stats, but I think I need another separate one for math. So see if I can get that overridden.
Yeah. Yeah, at least like 3 years ago, stats 241 counted towards my math major, and stats 242 counted towards my computer science major, something along those lines. So that was kind of convenient. But yeah, I don't know anything about the math minor, sadly. But yeah, so it is 7 p.m. I'll make a last call for questions here. And end the recording. Yes.